Hi, welcome back to WSHS Virtual Tutor for Math. In geometry today, what we're going to be doing is working on quadrilaterals and polygons. So we're going to be doing a couple of different targets here, but the target for today is applying the properties of quadrilaterals and solving for missing segments or angles. So here's your target statement. I can apply the properties of quadrilaterals to solve for missing segments or angles. Okay, so we're going to have to solve some problems here and solve for x, solve for y, but we have to know specific things about the quadrilaterals before we can set up our equations in order to solve, and that's what you're going to learn today. So you might already know the names of some of these quadrilaterals, so we're going to do a little quick review. For number one, do you know what this type of quadrilateral is called? And a quadrilateral, obviously you can see all of these shapes here, is a polygon. And polygon means shape. But the quadrilateral specifically, quad means four, right? So a polygon with four sides. Okay, so we have a bunch of different types. So this is just a quick review. This one here is not a rectangle, but this one is known as a parallelogram. For number two, you might know this as a rectangle. And I know it's a rectangle because I see that these opposite sides here, 7.6, 7.6, 14.4, 14.4, those are all congruent, right? So opposite sides are congruent. You might already know that that shape is a rectangle. For number three, you can see here that all these sides are the same. So you might know this as a square. Number four, do you know what this one is called? I see these little tick marks, which you learned a while ago that all four sides are congruent, right, if they're all marked with the same marking. But is this necessarily a square? And it's not, right? It's not a square because if you look at these two lines right here, squares typically have straight lines, right? Straight horizontal or straight vertical. My drawing wasn't very good there. But these two slanted lines right here actually cause it to not be a square. This is known as a rhombus. So a rhombus is similar to a square, except it's sort of like a slanted square if you look at it. Number five here, this is still four sides, right? But if you notice, one of the sides is really slanted. We have a set of these, the symbol here means parallel lines. Okay, and so this type of shape, you might have heard of this before, this is called a trapezoid. And with number six, this is also a trapezoid, but this is a special kind of trapezoid because if you notice, we have two congruent sides, right? So these congruent sides, anytime you have two congruent sides, that special word you learned before was isosceles. So this is known as an isosceles trapezoid. Okay, so it was just a quick review to see if you guys knew what types of shapes these were. But these are all known as quadrilaterals. Okay, so this is the quadrilateral family we've got here. And in this quadrilateral family, we're going to start with the very top one that we see. And the very top one is like the grandmother of the family. So this is actually just known as a quadrilateral. Quadrilateral is a polygon with four sides. So you have two types of quadrilaterals. So you see how it breaks down into these two sections. The first type of quadrilateral you'll have looks like this one here, and this is called a parallelogram. Okay, so I'm going to break the parallelogram down even further. So within the parallelograms, then there are two other types of parallelograms. So the first parallelogram we see here is known as a rectangle. The second type of parallelogram we see here is known as a rhombus. And then that leads us to our very last quadrilateral down here. And rectangle and rhombus kind of merge together to create a square. Okay, so the way this flow chart works is this is saying that a quadrilateral can be a parallelogram. A parallelogram could be either a rectangle or a rhombus. And then you have the option of also becoming a square. So I would consider this C here. Now, when working backwards, a square can be known as a rhombus or a rectangle, but a rectangle cannot be the same as a square. So it kind of works going from the bottom up. And we'll talk about more about the actual rules of these in a little bit. Okay, a rectangle can be considered a parallelogram. A rhombus can be considered a parallelogram. Okay, then we've got the other type of quadrilateral, which is called a trapezoid. Okay, and then the trapezoid can also have a scenario where it's an isosceles trapezoid. Okay, meaning it's got two congruent sides. Okay, so this also works backwards, right? An isosceles trapezoid can be a trapezoid, but we can't say that every trapezoid is isosceles unless it has those two congruent sides. So there's specific properties that you'll learn more about these. Okay, but this is essentially the quadrilateral family. All right, so the first one we're going to break down is the parallelogram. Okay, so you need to know the four major properties that the parallelogram has. Well, one of the main ones that you can determine here, and we're going to use this because we see this word parallel, right? We know that we're going to have some sets of parallel lines. Okay, so what we're going to first write down is the first property here, opposite sides are congruent. We also have opposite sides both sides. I just realized I merged two words into one. Okay, let's try that again. Opposite sides are congruent. Remember that symbol, right? Opposite angles are congruent. Then we also have this property, consecutive, and you've heard of this before. Consecutive angles, you remember these from parallel lines and transversals, right? Are supplementary. So remember, supplementary means that they add up to 180. Okay, so this is more focusing on like the same side. So same side, right? Consecutive angles, same side. And then we have the fourth property, which mentions that diagonals bisect. You remember this word? Bisect each other. So remember, the word bisect means it's broken down into two equal parts. Okay, so knowing these properties, these four main properties, we're going to be able to solve a couple of problems that have to do with parallelograms. Okay, but before we do that, I wanted to make sure we had a quick review of parallel lines and transversals and those properties and what happens there. Right, so if I wanted to know the measure of this angle here, then I could use this 99 and use the properties of parallel lines to tell me that these two are corresponding angles, right? So corresponding means that they are congruent. So if this one here is 99, then that means this angle is also 99 because it falls in the same spot. Okay, on the other side here, we can also remember, because we're going to be using these properties for our parallelogram, right? So parallelogram has parallel lines as well, which is why we're kind of reviewing this to make sure we remember what parallel lines help us determine. Okay, so if I know that this angle here is 50 degrees and I'm trying to find this angle right here, these are called consecutive interior angles, right? And consecutive interior angles are supplementary. So we add them up and they would equal 180. Right? So I would have 50 degrees plus whatever the missing angle is, and my total together would be 180. So I would find what the missing angle is by subtracting 50 to both sides, and that would tell me that my missing angle is 130 degrees. So we can use these same properties in addition to what we know about parallelograms, and we can solve these problems. So this first one here says solve for x in each parallelogram. Well, what I have down here, these are the same on the same side, right, of my parallelogram, same inside there. And these are also known as consecutive interior angles. Because if you look, these lines here, if they were to continue on forever, they would be parallel lines, right? Cut by this transversal right here. So you could see that these two here are consecutive interior angles. So together, I can set this equation up by adding them and setting them equal to 180. Okay, so what I would do here is I'm going to have to combine some like terms, right? So to combine like terms here, you get 15x plus 105 equals 180. And then from here, you would have to solve for x. So we're going to have to subtract the 105 to both sides. So we get 15x equals 75. And then we're going to divide by 15. And we get x equals 5. So that would be our answer. Okay, so let's look at the second one. I have to solve for x for this one as well, but this time I don't have consecutive interior angles. These are actually corresponding angles. And the reason why I know that is because if I were to extend, again, extend these lines and extend these, okay, I can see that if this is place number 1, place number 2, place number 3, place number 4, and I were to shift that down over here, this would be place number 1, place number 2, place number 3, place number 4. Right? So technically this -5 plus 23x is the same as this piece here. Negative 5 plus 23x. Now the relationship between these two is that they are vertical angles, right? Okay, so because they're vertical angles here, what we can do, we know vertical angles are congruent, so we could also set them equal to each other in order to solve this one. So here we have 22x equals negative 5 plus 23x. So we'd have to solve for x this way. What I'm going to have to do is subtract 23x to both sides. Okay, so that leaves me with negative 1x equals negative 5. And then to solve for x, I would have to divide by negative 1. And I get x equals positive 5. So for these two, we happen to end up with the same answer. Not always necessarily the case. That's how this one worked out. So you want to apply the same rules for parallel lines and transversals as you would in a parallelogram. Okay, and this second one here, remember we said also what we could have done is because we know that opposite angles are congruent, that also worked in our favor for this one, right? Aren't these opposite angles? They're opposite of one another, so they are congruent to each other. Okay, so what we're going to do now is this one. See if we can figure this one out. It says find x and y so that each quadrilateral is a parallelogram. Okay, so we know from our rules opposite sides are congruent, opposite angles are congruent. So if these are opposite sides, then those two are congruent. These are opposite sides as well, so those two are congruent. So the first one I'm going to take care of are my x's. So I want to set these two equal to one another because opposite sides are congruent. So I'm going to solve for x here. Subtract 2x to both sides. So you get 4x minus 12 equals 36. Add 12 to both sides. And you get x equals 12. Okay, then I'm going to solve for y here. Again, opposite sides are congruent, so we can set them equal to each other. Okay, so I would subtract 6y to both sides. We get negative 2y equals negative 42. Divide by negative 2. Y equals 21. Now, what you want to be careful with are your signs, okay? If you happen to be doing the math and you wind up with a negative number, or when you plug it into the side, you get a negative answer as far as your sides go. Can you have a negative side of a shape? Can it be a negative side? No, it cannot. We got to kind of remember like the rules of absolute value, right? So if you're, like, say, geometry, we build things, it's all about shapes and things like that. So if you are measuring the side of your desk, let's say, to see how big your desk is, would you end up with a negative number? Do you have negative measurements on your measuring tape? No, you don't, right? So you want to always double check and make sure that your signs are correct and that you're doing the math correct. Okay, we'll do one more parallelogram here. It says, in the parallelogram below, WH equals x plus 6 and HY equals 2x minus 3. Find x. So what you want to do is first label, see what we have here. So WH is right here. So they're telling me that this piece is x plus 6. And then they're telling me HY, which is this piece here, is 2x minus 3. Find x. Okay, well again, one of the properties of the parallelogram says that the diagonals The diagonals bisect each other. Okay, so remember we said the word bisect means it cuts into two equal parts. So I can say, knowing from this, that this piece, x plus 6, is equal to this piece, 2x minus 3. So I can go ahead and set up my equation that way. So x plus 6 equals 2x minus 3. We're going to solve for x here. So we get 6 equals x minus 3, and x equals 9. Okay, so that's how we would solve parallelograms. The next one we're going to talk about are rectangles here. So rectangles have the four major properties as a parallelogram. So remember, in our flow chart, the rectangles were underneath the parallelogram, right? So the ones that are underneath have the same properties as everything that's above it, but sometimes they have additional properties as well. So in addition to everything the parallelogram has, we're going to add 2 more points on for rectangles. So with rectangles, we also know that the diagonals are congruent and all 4 angles are right angles. Okay, that's a little symbol there. You know, right angles add up to 90 degrees, right? Or they measure 90 degrees, not add up to 90 degrees. They measure 90 degrees. Okay, so knowing that, we're going to go ahead and do this problem here. So it says rectangle VWXY. We should label that for you. VWXY represents a park that has walking path Vx and YW that intersect at P. The length of PW is 300 feet. So that's some important information here. PW is 300 feet, so we want to make sure we label PW. And the length of VW is 450 feet. What is the length of Vx? So what would this piece be right here? Vx is the entire thing, right? Okay, so knowing the properties of the rectangle, we said here that the diagonals are congruent, right? But we also said that a rectangle is similar to a parallelogram in that the diagonals bisect each other. So in a rectangle, if this piece is 300 right here, then this piece is also 300. And because the diagonals are congruent, then we can say that if WY adds up to 600, and it is congruent to Vx, then we can say that Vx is also 600 feet. Okay, those for rectangles. Let's talk about rhombuses, which actually that's incorrect. It's not called rhombuses, it's called rhombi. So a rhombus would be the singular, a rhombi would be plural. So rhombi have the 4 major parallelogram properties as well as these 2. So again, a rhombus was underneath the parallelogram, right? So it has everything the parallelogram has plus these 2 properties. So in addition to all that a parallelogram has, it also has all sides congruent, and the diagonals are even more important here because they perpendicularly bisect each other. So the diagonals are perpendicular bisectors. So not only do they create a 90-degree angle, they also form two equal parts as well, right? Because a perpendicular bisector does both. It cuts it into two equal parts, and it makes it form 90-degree angles. So let's see this type of problem. This is a past SOL question as well. So it says here, given parallelogram QRST, where QR is 6x minus 5, RS is 4x plus 13, what value of x proves that this parallelogram is a rhombus? So the properties of a rhombus mention that all of the sides are congruent. So we know if we have two sides, these two sides here, whatever this is going to be equal to this one. So we want to make sure we set that equation equal to one another for both of those sides there. Okay, so when you solve it, we're going to get 2x minus 5 equals 13, because I would have had to subtract 4x, right? Then we have to add 5 to both sides here. We get 2x equals 18, so x equals 9 when you divide 18 by 2. All right, another parallelogram question here that has to do with a rhombus. This one says ABCD is a rhombus. So it gave you that hint there. So we know that all the sides are congruent, and we also know that the diagonals are perpendicular bisectors and create 90-degree angles, right? So it says this rhombus has a measure EBC. So EBC is talking about this one here that's 36 degrees. What is the measure of angle DAE? So make sure you're labeling everything, okay? So DAE, they're talking about this one right here. So that's what we're looking for. Okay, so these diagonals are perpendicular bisectors, right? So that means they would form 90-degree angles all the way around. Okay, so if you look here, and we could also see, and we could apply this property here. We know that, let me do this in a highlighter here so you can see it better. We've learned previously as well that if we form an N or a Z, we usually have alternate interior angles, right? So if this measure is 36 degrees, then this measure is also 36 degrees. Okay, so now we have, looking at this triangle, this whole triangle right here, I have two angles, I'm just missing that one angle. So we know that the sum of the interior angles of a triangle measure 180 degrees, right? So in this triangle here, and I'll draw it separately for you, if this is 90, this is 36, what would that one be? So we would take 180, because all of them add up to 180. We can subtract the 90, which would be the 90, right? 90 degrees left over. Then we're going to subtract 36 as well. And that would give me whatever is left over here. So 90 minus 36 is going to give me 54 degrees. And this was also an old SOL question. Okay, and then last you're going to have something called a square. So if you have any problem that has to do with a square, since the square you could see is also a type of rhombus and it is a type of rectangle. But the square has all the properties of a rhombus, all the properties of a rectangle, all the properties of a parallelogram. Okay, so with the square, we have all 90-degree angles on top of all of that. The diagonals still bisect each other. Perpendicular bisectors form 90-degree angles, and all the sides are the same. Okay, last part here, trapezoid. So the trapezoid was on the other side of the quadrilateral family, right? So this is what we're going to talk about next. With trapezoids, they have two main properties. So they do not have the same properties as a parallelogram, rectangle, rhombus, square. They have their own separate set of properties. Okay, so you want to make sure you understand that. With trapezoids, they have two main properties here. The first property, we know that they have one set of parallel lines. That's what we're going to write here. Only one pair of sides are parallel. So that's the symbol for parallel, right? And what's something special about trapezoids is we can also find the median, which is equal to the average of the sides. This is a special one. If we have an isosceles trapezoid, the only difference really is that they have two sides that are congruent, right? So what we can say here is they're going to have the same thing that the regular trapezoid has, but plus these two pieces of information. The diagonals are congruent, and the base angles are also congruent. Okay, so we're going to work out two problems of these and then we're done. All right, so it says find the measurement of the indicated angle in each trapezoid. Actually, we might have a couple more than two of these. Okay, so if we have this one here, this is my set. If I look here, this is the 60 degrees, right? And I'm looking for this one. Do you see how these two lines are parallel, right? Remember, we said trapezoids have one set of parallel lines, and these are them. So we can apply the rules of parallel lines and transversals. And we could see that if this is a transversal, then these two angles are actually consecutive interior angles. So we know that they would add up to 180. So I can take 180 minus 60, and I can find the missing angle is 120 degrees. Okay, if I look at this one here and I want to find this missing angle over here, find the measurement of the indicated angle in this trapezoid. Well, I know here that this is 110 degrees, and we have an isosceles trapezoid here, right? So we said if I'm looking for this angle, it says the base angles are congruent. So this is one of my base angles. This is my other base angle. So these two would be congruent to one another. If I notice, these are the parallel lines that I have, and these two just formed consecutive interior angles, just like that last one. So again, they would add up to 180. So I can take 180 minus 110, and I can find that this angle R right here is 70 degrees. So if this is 70 and my base angles are congruent, then this angle over here is also 70 degrees. Now we're going to solve for x here. It says here that SU, which is this whole piece right here, is 15. And then it says RT, which is this whole thing right here, is 2x minus 1. So part of our properties for trapezoids said that the diagonals are congruent. And this was an isosceles for isosceles trapezoids, right? Because we see this piece of information which tells us that the sides are congruent. So if those are congruent, then the diagonals are also congruent, so we can set these equal to one another. 2x minus 1 is 15. So we should get x equals 8. Okay, and last two, I promise. So we also mentioned something about medians with trapezoids, so I wanted to make sure I cover that here with you. It says find the length of the median of each trapezoid. So we know median is middle, right? So with the trapezoids, we said that the median, this median, is equal to the average of the other two sides. So we're going to take these two, and you find the average by adding them up and dividing by however many you have, right? So 37 plus 23 divided by 2 is essentially what we're doing to find the median here. So when we do that, what we're going to get is when we add them, we get 60, and 60 divided by 2 is 30. So this would be 30. And it's not degrees because it was talking about the length, not the angle, right? Okay, so taking that into consideration, we can now do this algebraically. Solve for x, and it tells you here that this is a trapezoid. So knowing that, we see this is the middle, right? This is my median. And the median is found by taking the average of the sides. So we're going to add 7 plus 13. Okay, we have to do that first, and we're going to divide this by 2. So 7 plus 13 is 20. 20 divided by 2 is 10. So it's saying that this is equal to 10. So now we can use that information and solve for x here. So 4x minus 26 is 10. Oops, I'm already giving you part of the answer. We're going to add 26 to both sides, and that's going to give me 36. That's where that 36 came from. Sometimes my brain moves faster than I need it to. All right, so we're going to divide by 4 here, and x equals 9. And that is it. That was properties of trapezoids and then solving using our properties of trapezoids. So that was the end of our lesson for today. In the next lesson, we're going to do a little bit more with quadrilaterals and get further into this.